Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, we are from JCDCS1103A from subject MAT 210. So today in this video, we are going to tell you about directed graph. Before we start, I am going to introduce to you my fellow group members. First, we have Qayyim, and second, we have Fadhlan, and lastly, we have Hassan. So let's get into the video. So everyone, what do we know about directed graph? Directed graph contains vertices and a directed line that's connected those vertices. So everyone, do you know where do electricity comes from? Well, let me tell you. Electricity starts far away at power stations. Then the big power lines that you guys see acts like a special road for it. There you can see a transformers and a smaller lines that bring electricity to our home. Okay, now let us continue. First, see the drawings. Do you guys know which way or which is the electricity comes from and where does the electricity go to? It's hard, right? So this is where the directed graph comes. It makes us easy to understand. Look at the vertices. Okay, when those lines have directed lines, we know where it comes from and where it go to. From the previous drawing, we can see that the first drawing is hard to understand because of its symbol and the not directed line. The second drawing that you guys see is a simpler and easy to understand because the vertices that use is a standardized symbol and the lines that is used is a directed line. So directed graph is easy to understand, standardized symbol and simple to create. Okay, now let me teach you how to implement it. First, we have dots, which is vertices, and then we have lines, which is a directed line. If we combine them, it becomes a directed graph. So let us create a power grid directed graph. For the first vertices, we put it as a power station. Next, we put a directed line which is directed to a house.
So now, let's take a look to our case study or an example for this problem. We want to supply electricity to Segamat City and UiTM, but it will go through two checkpoints before it reach it. The three checkpoints of electricity is first, a step-up transformer, distribution transformer, step-down transformer. But the distribution transformer is located between Segamat City and UiTM. So, we have our problem, and then let's take a look to our answer. First, we need to verify all of our variable to a simpler or shorter terms and make it our vertices so we can read it more easily. We can take it from our problem statement. So first, let's take our both destination as X and Y, which is X as Segamat City and Y as UITM. After that, we need to take our 3 checkpoint, which is step up transformer as UT, a step down transformer as DT, our distribution as DI. Make sure the name is short form from the original name so we can read it clearly. And lastly, POW as our power station. So now, we have all of our vertices that we needed to make a directed graph. So, the last step is to arrange and make a directed graph that we can easily read and easily understand. And it needs to be according with our problem. First, we put DI or distribution transformer in between X and Y first. This is because from the problem statement it stated that distribution is located between X and Y, or UITM and Segamat City. After that, we will put up transformers and also power station. You can put both of these vertices anywhere that you like because it is not particularly important for the arrangement as long as distribution or DI is between X and Y. Next, we put the DT or down transformer, and we have all of our vertices. Now, all that we need to do is connect all of our vertices with an edges. Oh, but make sure DT we classified it as DT1 and DT2 as it has two things that is the same, and we don't want to be confused. Now, let's start with connect the power to the distribution center, but go through the up transformation first, and then from distribution center we will go to down transformer and then go to the X or our destination, and then repeat the same step as before from distribution center to the Y by make sure go through down transformer first, and then after we have done go to both our destination, we need to go back to our power station, as power station is an electrical current and current must be done in circuit. And then that's all of our answer.
So for the chart on top, I will talk about the summary of our project. From the summary, we can conclude that the powers that travel from far away to our homes, it go through a well-organized system, which means the system of the power travel need to be well organized or not be messed, so the travels of the power will be more efficient and not stuck and be messed. And the system is like a special road. What I mean by the special road? From the special road, each of the city have its own road, its own way to reach their destination. That means that the electricity will be flowing smoothly. Why it becomes smoothly? Because it has a special road and will be not sharing with others. It will deliver the electricity without any delays. And for the lastly, we can be conclude also that the math graph will help us solve our problem of building a power grid. Why we can say power grid? Because in a math it has a directed graph that we can be used to make or be sketch our power grid circuit, which means where from input and output of the power grid, so we can avoid any half inefficient way or any wastage of the power travels. Well, that's all from us now. Thank you for leering your ears and your eyes for our video. I would say like thank you. That's for today. Me myself, Fadhlan, Qayyim and Hassan would say bye bye.